Hello everyone, welcome back to my channel Code Genius Riya. So in our last video we have read about what is microservices and what is the difference between monolithic architecture and microservice architecture. Now you might currently think that microservice is easy, like take a feature, wrap in a service and that's it. Well, the reality is not that. We have the big challenges. What big challenges? Like we start to run into, like, one of the really big challenge is data management between services. This is the biggest problem that microservice has, and this, like, 90% of this course will going to focus to resolve this. And we are going to use the methods that in future you will see in engineering, as well as you will see in real time that we are using one of this method. So why? Like, data management means the data in which we store the data inside of a service and how we communicate the data between different services. It is huge obstacle to effectively use microservices. So, like, why data management is big problem? So with microservice, we store access data in sort of strange way. Like, why? Like, let's look at two different ways, like how we store the data and how we access it. In microservice, the way we store and access data is just a little bit different than what we might used to do with a monolithic architecture. So first of all, I will tell you how we store the data. To store the data, like, we have different database. So each service gets its own database if it needs one. Okay. If service does not need a database, that's fine. We are not going to give it one. If it needs, then we will give and provide the database to it. Okay. I will tell how we can't access data. So we are not going to access data by reaching from one service, like service A, into another service database, that is service B. So under no circumstances will we ever have service A try to reach out database for service B, because in that case, if service B goes down, then service A will automatically fails and crashes. So that's why we are not going to use this. Like, service A will never ever reach out to database of service B. So now we have like two big reasons, like each service gets its own database if it needs one, and another thing is service will never ever reach into another service database. But why? Like, what is the reason behind it? So we are going to use database per service. What does it mean is, like, to give service its own database is known as a pattern. The pattern is called database per service. Okay. So if I talk about the first point, that is why we want each service to run independently of other service. For this, suppose we have service A, service B, and they are trying to access the database, like the data, where is the data for everything, like service A, B, everything data is contained inside this database only. So suppose we have every service using the same common database. Here we call it database for everything. The problem with that approach is that if anything bad ever happens to this database, all of our service is going to crash immediately. The other big problem is that scaling this database right here would be really challenging. If every service inside of application uses the same database, service A and service B, we are going to have to scale up that one database instance or that one database to service all the different services of our app. If suppose we only want to scale up the database for service A, but it will entirely scale up database for everything. So that's the biggest problem here. But we have to think, it would be a lot easier to scale just the database that need additional capacity. Other scenario that we could run in, imagine that we have like got service A, and what happened, like imagine that service A reaching out the database of service B. If anything ever goes wrong with the database B, then all of a sudden service A is going to start crash because we have introduced a dependency between service A and service B. So if a request come into service A and feature A tries to reach out ever to database B and something is wrong with that database, like boom, service A is going to crash as well. Rather than just losing service B, we would now also be losing service A by giving each service its own database and making sure that each service only use its own database. We dramatically increase the uptime of a system. So now the another challenge is like database schema structure might change unexpectedly. So for that, let me take you with this diagram. So imagine like service A reaching out directly over to database B. This is not we want. Suppose feature A usually runs a query like get user, this one, inside database B. And usually data B, like database B, what returns? It returns Jill, an object that has a name Jill or something like that. Like whatever the name is, point is key of the name. Imagine for some reason like service B team changed the schema or structure of database B, rather than like giving every user like property. Maybe they want a like name changed to first name. Suppose database B has changed the name to first name. Now, like the team in charge of B does not tell team in charge of A about the changes of the schema right here. If that would happen, next time service A makes a query to database B, they get back an object that has first name property instead of name. Service A probably not configured to expect to see a property of first name. Now we might start to have some issues start to arise in service A, all because we try to rely upon a database located in a different service. So that's why we are not going to use this. So how like some service might function like more efficiently in different types of database, SQL versus no SQL. Like third reason, maybe like one service can run more efficiently like with MongoDB, other can be PostgreSQL or SQL. So that's why we can't depend only on one database. We will more efficiently using different database in our microservice. I hope you will get the point. Thank you.